So our next speaker is Dr. Alon Kaufman from RSA. Quick quiz, what does RSA stand for? Private names of Rivest, Shamir, and Adelman. No one? Okay, Ron Rivest, Adi Shamir, and Leonard Adelman. It's very easy. The next question is, what are the private names of Sarbens and Oxley? Of SOX. Okay, never mind. So, this is yours, yes. Dr. Kaufman is RSA's Director of Data Science and Innovation globally, operating from Israel, leading all data science and big data aspects for RSA across the full portfolio. The team includes many researchers, mostly PhDs in statistics, physics, machine learning, computer science, boring stuff, as well as big data engineers, innovation strategists, and security experts. Prior to joining RSA, Alon held several managerial and research positions in Israeli high-tech companies, dealing with various aspects of data mining, data science. All in all, have over 20 years of experience in technology and innovation management. He holds a PhD in computational neuroscience and machine learning from the Hebrew University. This is not us. And an MBA from Tel Aviv University. This is us. Teach data science courses at Ben Gurion and Tel Aviv University, and a public speaker on big data and data sciences, cybercrime, security, innovation, etc. He will speak about data science transforming security operations. Alon, please.
Does this work? Yeah. One. It's okay? Excellent, excellent. I prefer not standing behind the podium. So thanks for this long introduction in the hour. Don't worry, I'm not going to keep you too late, and I'll try and catch up in the times. So yes, I'm going to talk about how we at RSA see data science as a key technology transforming the way security is done. And basically, I'm going to take you through this, and if time allows, give you 2 or 3 concrete examples of what I mean. So I'll skip this slide and go into details. I don't have to talk to you about the threat landscape. We all know it's getting more complex, more aggressive, more destructive, more disruptive. We've been attacked on anything from everything, and that's really the world that we're all dealing with. And on the other hand, we have really the security operation model, which basically all the technologies we've been talking about and seen basically fall into these main buckets. And this is also true for any kind of security. We collect evidence when something looks bad, we detect something that looks abnormal or creates an alert. We go, we investigate it, we learn what happens, we validate it was really an attack, and based on that we go and we put a response, and we actually stop that from happening again and try and put new controls. So that's what we're all doing for many, many years, and the situation looks bad. We're basically losing this battle. And nicely, Tamar referred to these numbers, and Ophir referred to this special graph, which really talks about the fact that more than 90% of the attacks or the breaches happen in less than a day. However, in terms of the detection, the minority are detected in less of a day. And maybe the worst picture here is that these 2 graphs are slowly opening. So we're constantly losing this battle and doing something wrong. So what is actually happening here? We have the technologies, we have the money, we have the brains, of course the hackers as well, but what is fundamentally happening here that we're losing? And I'm not talking about a specific technology, as Ophir said, each startup is sure that his technology is the one that's going to solve this. What is really the nature of this battle that we're losing? So first of all, if we think of it, the attacker's world is much more known. They know what they're after. It's much more predictable. So they decide when they're going to attack. They know what they're after. They know what the tools are there. We, the vendors, explain our tools all the time. They know exactly what the target tools are there. So for them, the world is much more clear, predictable, ability to plan, and so on. So their lives are, in that sense, much, much easier. Versus our lives as defenders, the attacks can come from anywhere, anytime, and on any kind of system. So they just need a small hole in our system to get in. And we have to basically patch and close all these holes, which actually creates the fact that the way we do security operations today in that model is very, very slow. It's reactive by nature. You could even say that we essentially wait to be attacked in order to investigate it and put the remediation for the next time. The other thing is that the way we do security today is heavily based on specialists, on security specialists. And there's becoming a huge, huge gap. There's not enough people, and those that are there are actually worn out quite quickly. So even the people that are running this machine, we're starting to run out of them. And another thing is we simply don't make their lives hard enough. So we know about compromises, or organizations attacked, the attackers can attack one organization and the others don't go and patch themselves against them. So in many sense, we just enable them again and again and again to use the same attack methods across the different organizations. So this is just one point of looking at the problem from a little bit different angle and really asking, why are we in this reactive, slow, human-skilled kind of operation method? So before I try and answer this, and I'll give you a few minutes to think, I want to shift to a different area. Anyone knows what this picture is? Excellent. It's Aviation Radar. So this is the radar that was introduced into the F-4 fighter planes in the 60s. And it was the first radar in fighter planes. And the goal there was to see beyond view range. So pilots can see 5, 6, 7 miles. And now they wanted to go and see beyond that to the 20, 30 miles. So they went and created a radar, which, by the way, definitely did increase the visibility. Suddenly you could see different planes or different elements further out. So to increase visibility, to operate this radar, you basically had to put the beam in the right azimuth, put it in the right elevation, play with a game just to detect the targets and lock on them. And in this case, it was, in this case, it was very prone to noises and ground terrain, and even birds and so on used to disrupt us. But at the end of the day, it gained visibility. It became the very skillful kind of tool to use, but people that knew to use it very, very well. And it even required additional hand count. It basically doubled the hand count. So fighter planes before that were one-seated. When they introduced this, McDonnell Douglas introduced it, it actually became a two-seater plane with a system operator or a co-pilot sitting in the back operating the radar. So that's where the world was to create this visibility. We jump 50 years forward, and this is what's called the TSD, a Tactical Situation Display of the F-35. What you actually see here is a screen with all targets in the area. So like the radars screen all the area, lock on all the targets there. Each of the targets is mentioned, is it an enemy plane or a friend, if it's a ground or an air kind of thing, what missiles it has, what threat it has, and in many senses and in many cases it even applies automatic electronic countermeasures. So what actually happened in this 50 years is increased visibility, much more. This is what one would call now situational awareness. You really know what's going on in your area. You're getting information from all your formation or any other kind of system that can add to it. It's responding automatically, It's responding in many cases automatically, and in this case it reduced head counts. So the F-35 is now again a one-seater fighter plane. So to carry on the analogy, I'll just go to this example. Anyone knows what this is? Google car. So what is actually the role of the driver in this transformation about 100 years in the automotive industry? The driver, finally after 100 years, just tells the car where it wants to go and doesn't have to do anything else. Similarly, in the aviation area, so 100 years ago, pilots really had to fly planes. And today with the new planes, they don't really fly them. They basically decide what the plane has to do, and the plane does it for them. So in many senses, what actually happened in these two examples is the role of the human being moved from operating and manipulating the system to actually using it. So telling the car from where to go from A to B, or telling the aircraft what targets it has to deal with. In security, we probably are still in this area. So if you look at CERCs, if you look at the security operations, most of the people spend most of the time manipulating, fine-tuning their systems, and not really operating based on what they are. So we are slaves to the system and not really using them in many, many senses. So I'll say that again. Most of our security analysts spend their time fine-tuning and configuring the systems, working for the systems instead of using the systems for what they do. And that's a critical component that leads to where we are. How are we going to try and solve it? So we have all these point solutions. So we have all these radars. Each of them gave additional visibility. Each of them is now a solution that you have to fine-tune and so on and so forth. Some of them are better than others, but each of them has the next gen and next gen, and we'll have it continue to have more and more generations. And the idea is basically to take all these point solutions that we have and combine them into a much broader system that really can leverage what they have to offer. So you can imagine this as a room of experts. You have an experts in each kind of field. You really want to combine all your experts to provide some knowledge. Now, by combining these experts, by getting them to work together, by the way, the point experts are also going to learn and improve. So if the biggest complaint to some of these systems are false positives and all kinds of things like that, by combining them and by helping them learn from the other experts, from the other systems, this is even reduced. Moreover, if in a specific incident, one or two of these have a false alarms, but in others not, so the system can overcome it. So what we really want to try and do in this world is combine all these solutions into one big system that really provides you a much more comprehensive, accurate view of the world that can help you to operate on it much more efficiently and learn by itself. So imagine that the security expert comes into the office in the morning to the circ, and instead of choosing what to work on, he sees a picture like this. A radar telling me, okay, what attack is most important to deal with now in terms of how much it's risky and how much impact it's going to give. This is what we really want. We want this radar concept to be there, and of course with all the supporting evidence around it. So instead of a bottom-up approach, detecting all kinds of alerts and trying to combine them, we want our analysts to actually work from the top down. And of course, this view to provide much more comprehensive view of the world, as exactly like the TSD, the tactical situation display of the F-35 we spoke about. Now, it doesn't really change our detect, investigate, and response model. It's just detecting, responding, and investigating on a different level. So we're not interested in detecting only single points. We're interested in detecting really attacks, detecting, if you would like, the kill chain, and not small evidence. We want to have everything prioritized, everything aggregated. So everything related to the same attack should be combined together, and maybe even predictive, telling us what is the next step there. Obviously, investigation has to be a top-down concept, and every time the analyst investigates something, the system should learn to do it the next time. Anytime investigation is ended the right way, the system should learn. Every time it's ended in a non-sufficient way, the system should learn as well that that's not the way it's doing. We don't want our analysts repeating their work again and again. And of course, respond. Anything that can be automatic, anything that can be learned, and using the human intelligence really in the places that we can't do it. So, I'm a data science guy, as Niv mentioned, and data science for me is one simple thing. You have a goal, you have a problem, you have data, and data science is the art of basically connecting them. So we have the data, we have our goal, and basically one of the key technologies to bridge this gap is using data science. Now, in most places, you'll see data science only in the detection phase. So saying, this user behavior analysis and anomaly detection, it's meant for the detection phase. But no, we at RSA are building it out in all the levels, from defining incidents of compromise, combining this into attack models or detection models, combining them into higher level detect, combining this with the investigation phase, and of course crowdsourcing and so on, in order at the end of the day to resolve in these points, which are not singleton alerts. They are actually attacks predicting how impactful or how risky they are to the organization, and how long do we have until we solve the problem. And obviously, I'm not going to talk about all these point solutions, and time is running out, I know. I just want to relate to two examples which goes well to what Tamar and Ophir spoke about. So the key thing is that you don't look at any element as a singleton element. So many IOCs are part of detection models, and many detection models are part of an attack. So let's just look at one example. Let's look at detecting a suspicious VPN login. So I'll run through this quickly. But basically what you see here is, in this case, in our system here, we have 30 different indications of compromises, which are like things like what country came from what device, what it done, and so on and so forth. For each of them, we actually build an anomaly detection kind of engine that detects how anomalous it is and gives it a risk score. So for this case, the user always comes in from a specific country, United Emirates, and then suddenly comes in from a new country. It's a 92. In this case, it's from a different device, a different number of data, and so on and so forth. So all of these IOCs already have a priority, and we combine them into one final score, how risky the VPN is. Now, great. So now we have a detector to do VPN detection. And great, that can be a nice model by itself, and it's way better than many, many other systems already. But you shouldn't stop there, because the next thing is that this user, when he logs in, you want to continue to see what he's doing. So in this example, this specific user not only logged in from the VPN in a very suspicious way, but then we started to see what was basically lateral movements that was mentioned before. He starts traversing different devices from different people in different organizations across the network. And so, by the way, as you see, the risk score goes up as he traverses the network until it reaches a higher score. And in this case, we don't stop here, and we look at also at when he goes into new devices or scans and looks for passwords and so on and so forth. So without going too much into this example, the key here is to chain things, chain IOCs, chain detection models, so on. And by the way, there's even an example here of adding crowdsourcing or community data to this. So whatever you found within your network is great. Let's go and ask what the rest of the world thinks about it as well. And starting to chain these things together and really get our visibility across the board, enable all these point solutions that startups and different companies are providing to all fit into one more holistic system that can really do the learning on top of it and assign the right weights to the product. So I'll just summarize here and say that the key here is really to build these systems in a way that they learn automatically and really change the analyst today from a person tuning and finding these things to someone really operating on a much higher level, going top down and really addressing the attacks versus fine-tuning the systems. And this is basically the approach we're taking around this topic. So thanks. Thank you very much.
Thank you. Thank you very much, Alon. It was very interesting. I just want to point out that the transformation between doesn't work, never mind, between the fighter, the 1905 plane and the modern plane and the Google car, it took more than 100 years to get it automated. We're in the computer business only for like